Hi, my dear friends and students. So, in this lesson, we are going to learn L.C.M of fractions. So, it is the very easiest formula, the shortcut formula. So, that shortcut technique I am going to reveal to find the LCM of fractions now. Let's see what is the beautiful formula to find the LCM of fraction. Let's see now. See, the formula is nothing but the LCM of numerators by H.C.F of denominators. Got the point? The LCM of fractions, you might know fraction means nothing but numerator by denominators. Only the just find the LCM of numerators and just find the H.C.F of denominators and divide them. Divide the LCM of numerators by H.C.F of denominators. Then you will get LCM of fractions now. Let's see how we can find by using this formula. Let's see now. I'm taking the one example now. The example is LCM of 2 by 3 and 8 by 9 and 16 by 8 and 10 by 27. How we can find the LCM of these four fractions? So there are four fractions here. The first one is 2 by 3 and 8 by 9 and 16 by 8 and 10 by 27. Let's find their LCM. So here I am taking the numerators as a formula, LCM of numerators by H.C.F of denominators. So that's why I'm finding C. Yeah, LCM of 2 comma 8 comma 16 comma and 10 by and H.C.F of 3 comma 9 comma 18 and 27. See, my friend, see, LCM of numerators by LCM of denominator. Here also, already we have learned the shortcut formula to find LCM and HCFs. Then same those techniques we can apply to find LCM and HCF. Let's see LCM of 2, 8, 16 and 10. See, already in the shortcut formula, see the LCM. To find the LCM, we need to take the largest number. Your largest number is 16, 16, and the remaining we need to check that whether the given all the numbers or whether they are factors or not. We have to see, or whether the 16 is the multiple of all other numbers. We need to see that. See, if you see, then here 2 is the factor of 16, so I'm cutting down this 2, and also 8 is also factor. I'm cutting down, and 10 is not a factor of 16, so here 10 is remainder. Now the remaining number is 10, but we should not multiply this. Why? Because these are not coprimes. If they are coprimes, we can multiply. So that's why I see. 1 minute. Let us remove. Yeah. See, in this case, what do we do? Then see, just the largest number should be multiplied with the numbers from the least natural numbers. Means from we need to take from 2. Then see, I'm multiplying with 2, and 16 twos are 30. Sorry, 32. But 32 is not a factor of multiple of 10. So here I'm not taking. And let us take 3 now. 3. 16 3 is 48. 48 is not a multiple of 10. And 16 4 is 64. It is also not a multiple of 10. Now 16 5 is 80. Now 80 is a factor of multiple of 10. So it is the least common multiple of 16 and 10. So that it would be the answer of LCM of this all the numerators. You can check it now for the point. And by let us find a HCF of 39827. Now 39. So they given that 3, 9, 8, and 27. To find the C, we need to take the difference of each two numbers now. The 9 minus 3 is 6, and 9 minus 8 is 1, and 27 minus 8 is 19, and 27 minus 3 is 24. So here we need to select the least difference. The least difference is 1. So the absolutely we have to take as HCF of 39827 is the 1. Got the point? Why? Because 1 is the factor of all the four numbers here. For example, if the least difference is not a factor of all the four numbers, we need to factorize the least difference. Again, we need to select the which is the factor of 39827. That is the last answer. That is the accurate answer of HCF. Now, for this question, the answer of LCM of 2 by 3 and 8 by 9, 16 by 8, and 10 by 27 is nothing but 80 by 1. Got the point? Was it easy? So let's solve another problem. Then you will get an idea how to find the LCM of 2 by 3. Sorry, LCM of the fractions now. Let's see. 7 by 3 and 4 by 6. Okay. Let's see. Write the formula. Then LCM is equal LCM of numerators by H.C.F of denominators, as we have learned already the first formula, first problem. So let us see now how does it work now. Now LCM is equal to LCM is equal to LCM of numerators. Let's see the numerators, my dear friends. They're 1 and 7 and 4. These three are the numerators. So these three numerators, if you observe carefully, then 1, 7, 4, those are co-primes. Nothing. Why? Because they have no common factor. 1, 7, 4. Okay? That's why all I told you, the LCM of co-primes is absolutely their product. That's why let us multiply given number to get the LCM. So 174, 1 into 7, 4. This is nothing but 28. 177, 7 fours are 28. Now let's see the HCF of the denominators. HCF of denominators. See, 2, 3, 6. So your denominators are nothing but 2, comma, 3, comma, 6. So, 1 minute. Yeah. 2, 3, 6. I already told you we need to take difference. 3 minus 2 is equal 1, and the 6 minus 3 is equal 3, and the 6 minus 2 is equal to 4. The least difference is 1. Okay, the least difference is 1. That's why the final answer is 1. So the HCF of denominator is always 1. So the HCF of denominator is always 1. Got the point? So it is the most and excellent and amazing, easiest technique to find LCM of the fraction. In simple, LCM of the fraction is nothing but LCM of numerators by HCF of denominators. The final answer is 28 by 1. Yeah, that's all for this lesson. Let's go to the HCF of the fractions. Okay, thank you. Hi, my dear students. My name is M.NARESH. So, as we are having a pandemic days of COVID-19, so many students are facing the problem with mathematics. So, many students are making phone call to me. They're asking doubts to me. So, yeah, I have started this program. This program name is Brain Booster Program. Brain Booster of Mathematics. So as this program daily, I will teach a topic, a shortcut technique. It may be a shortcut technique. It may be topic of your textbook. A clear explanation, step-by-step explanation I am going to give now. Okay. So yesterday, many students have made call to me and they have asked about the H.C.F, highest common factor, and the shortcut method. They asked me to explain. That's why today I'm going to explain about the highest common factor. Let's see the what is highest common factor. Now see H.C.F. What is H.C.F? H.C.F is nothing but it is the largest positive integer which divides two or more given numbers without remainder. Without remainder means with remainder 0. H.C.F is nothing but it is the largest positive integer which divides two or more given numbers. Means the H.C.F is the common factor of all given numbers. All given numbers. So it divides each of number without remainder, means remainder must be 0. As we know that the numbers are two, whatever the given numbers may have the more common numbers, common divisors, common factors. It may be have two common factors, maybe have four common factors. But which one we can consider as HCF here? Means the largest common factor is known as highest common factor or greatest common divisor. The other name of highest common factor is the greatest common divisor or the greatest common factor. That's why we are calling them as HCF or GCD or GC or HCD. These are the names of HCF. For example, I'm taking 15, 15 and 20. The 15 and 20. These are the two digits, two numbers. We need to find the HCF. And usually, generally we take we divide 20 with 15. Okay, divide 20 with 15, and we can find it. For example, 15 ones are 15, and remainder is 5. Again, with 5, we need to divide 15. 5 threes are 15. So remainder is 0. So the year we consider 5 as here we consider 5 as HCD. But there is one shortcut method. See, only just no need of dividing here. The shortcut method is just to find the difference of 15 and 20. The difference of 15 and 20. So 20 minus 15 is equal to 5. So only just we need to say, we need to check this difference whether it is factor of 15 and 20 or not. We have to see that. Simple. Only just we have to see that whatever we got the difference must be the factor of 15 and 20. If it is factor, no doubt it compulsory, it must be the GCD of the given numbers. So already we have proven much more sense. So easily we can find by find the difference of the given two numbers. Let us take one more example. One more example for GCD. For example, I am taking 18 comma 32. 18 comma 32. We need to find the GCD of this 18 comma 32. Now let's see, as we discussed that, let us find the difference of 32 and 18. It is nothing but 40. But see, if you see that 14 is not a factor of 32 and also 18, then in this case, what we need to do means only just let us take the factors of 14, just factorize it. And what do you get? 2 and 7, and one more factor 14, and one more factor 1. These are the factors of 14. In this, we need to take the least factor of 14. So that is to be considered as the GCD of 32 comma 18. It's simple. What the point? Only the in this case is if the difference is not a factor of given two integers, then here we need to factorize the difference, and we need to select which is the least common factor. That common factor must be 32 and 18. Must be factor to the 32 and 18. For example, in the given, we have got the years, for example, we have got here 4 digits here. In these 4 factors of 14, none of them is factor of 32 and 18 then. So finally, we need to take 1 as a GCD. Got the point? So that's why, as we have got the 2 is the common factor of 32 and 18, here 2 be considered as GCD. Got the point? Now let us take one more example now. One more example. 22 and 17 I am taking, for example, 22 and 17. What is the difference between 22 and 17? It is 5. It is 5. See, as we have discussed that 5 is not a factor of either 22 and 17. So as we have said, I have said that let us take the factors of 5 and 5 comma 1. Here, 5 is not a factor of 22 and 17. It is not a common factor of 22 and 17. That's why the final answer is 1. So 1 is the GCD of 22 and 17. Finish. Got the point? So like this, we can find the H.C.F of 2-digit number by using this shortcut technique. Is it applicable for 3 digits and 4 digits also? Yes, it is applicable for 3-digit number and 4-digit number also. Then how can we find the H.C.F or GCD of 3 digits or 4 digits of number? Let's see now. Let us take 3 numbers now. Say, I'm taking 15, 22, and I'm taking 31. So let us take these two differences. The difference of 22 and 15 is 7, and the difference of 22 and 31 is nothing but 9, and the difference of 31 and 15, 16. So here we have got the 3 numbers, 7 and 9 and 16. In this, we need to take the smallest number. What is it? The smallest number should be taken. So in this 7 and 9 and 16, the smallest number is 7. And we need to check it whether the 7 is the common factor of 15, 22, and 31 or we need to see that. It is not a common factor of any numbers. So we need to take the factorize as this prime number. So 7 comma 1, it is only it has the 2 factors, 1 and itself. So as 7 is not a factor of any of this number, then 1 is considered the GCD of 15, 22, and 31. Simple. Only just we need to find the difference of 22 and 15 and 31 and 22. In very simple way, we can find this GCD. So like this, it can be applied for 4-digit numbers also. It can be applied for 4-digit numbers also. Let us see the one more problem. Let us take the 4 numbers now. Sorry, 22, 13, 80, and 71. Now let's see that the difference. Let us find the difference of any each two numbers now. I'm finding the difference of 22 and 13 is 9. The difference of 13 and 18 is 67. And the difference of 80 and 71 is 9. And the difference of 71 and 22 is approximately 49. So let's see now. We have got the 4 digits again: 9, 67, 9, and 49. As I said that the least number is 9. So, or as 9 is a so that's why let us take the factors of this one and 3 and 9 and 1. So the least one is 3, but here and 1 also there is the least one. So let us see that 3 and 9, but none of these three are there's 3 comma 9, both are factors of these 4 numbers. That's why the final answer is 1. So our 1 is the GCD of these 4 digits. Got it, my dear students? So this is the amazing shortcut technique to find the greatest common divisor of or highest common factor of the given digits. So practice it. If you have any doubts, please you can message me in the WhatsApp. You can send the message. You can ask me any doubt in the next live session. Thank you very much. Hi, my dear students and friends. So welcome to this lesson. In this lesson, we are going to learn H.C.F of fractions. So in the previous lesson, we have learned L.C.M of fractions. In this lesson, we are going to learn H.C.F of fractions. Let us see. It is an amazing mathematical trick to find the H.C.M of fractions now. Let's see. H.C.F of fractions. So there is an amazing formula to find the H.C.F of fractions. Let's see now. H.C.F of numerators by L.C.M of denominators, same as like L.C.M. How did you find the L.C.M of fractions? So we have found L.C.M of numerators and H.C.F of denominators. Here, further in the case of H.C.F, we need to find H.C.F of numerators. Was it awesome? Let's see how we can find. Take one example and let me explain with the example. Let's see now. Example, HCF of 3 by 9 and 5 by 4 and 2 by 36 and 15 by 16. Let's see how we can apply this formula to find HCF of these 4 fractions now. Okay, let's see. So the given fractions are here 3 by 5 and 5 by 4 and 12 by 36 and 15 by 16. For the point. Now I'm applying the formula. Now HCF is equal to HF is equal to, so we need to find the H.C.F of numerators. So numerators are 3 and 5 and 12 and 15. Here I'm writing, see my dear friends, 3, 5 and 12 and 15. Yeah. So generally, to find the HCF, we need to find the difference of each numbers, each two numbers now. So 5 minus 3 is 2, and the 12 minus 5 is 7, and 15 minus 12 is 3, and the 15 minus 3 is 12. Then finally, we need to take the least difference. So what is the least difference, my dear friends? 2. So we have taken the least difference, that is 2, and we need to check whether that least difference is a factor of all the numbers. But 2 is not a factor of 3 and 5 and 15, but 2 is a factor of 12. But whatever we select the least number, least difference, that must be the factor of all the numbers. So as 2 is not a factor of all the numbers, let us factorize the 2. So factorize, absolutely we know that 2 is a prime number. The factors of prime numbers are 1 and itself, so that's why 192. As 2 is not a factor of all numbers, so I'm not taking 2. Now the final answer is 1. For the point. So 1 is the HCF of the numerators. Now 1 by, now let's find the LCM of denominator as one. The denominators are 9 and 4 and 36 and 16. So here I'm writing, so 9, 4 and 36 and the 16. We are very perfect in finding of sort of LCM. So to find the LCM, then first we need to select the largest number of the given numbers. So the largest number is 36. So in this 36, we need to check that are there any factors of 36 in given numbers? Or we need to see that 36, whether it is a multiple of any number or not. See that. So 36 is a multiple of 9. That's why I'm cutting 9. And also it is a multiple of 4. I'm cutting down the 4. And the rest of the number is 16. The 16 is not a factor of 36. That's why we need to see and whether the 36 and 16 are co-primes or not. Absolutely, I say that they are not co-primes. So as these are not co-primes, so we need to multiply from 2 and multiply with 2. See, 36 twos are nothing but 72. So 72 is the 72 is the multiple of 16? No, it is not a multiple of 16. Why? Because 16 is the 48, 16 for the 64, 16 for the 80. So it is not a multiple of 16. And let's see, let us take by 3. 36 threes are. 36 threes is nothing but 108. 108 is also not a multiple of 16. So it is not in 36 into 3, we are getting 72. Sorry, 108. So where it is not a multiple of 16. Let's see 36 fours are. Now I am multiplying with 4. 36 fours are. Now let's see 36 into 4. Now 4 6 is 24, 4 is 12, and 144. Another one. So 144 is a multiple of 16? Yes, it is a multiple of 16. It goes in 8 times. 16 8s are 144. Therefore, the 144 is the common multiple of 36 and 16. So absolutely the final answer is 144 is the LCM of all the denominators. So our answer is finally HCF is equal to 1 by 144 for the DASM. So it is an amazing technique which we can find by which we can find HCF of fractions. Now let's see another example to find HCF of the fractions now. Okay, let's take an example now. See, the example is HCF of 1 by 9 and 7 by 5 and 16 by 45. Let's find the HCF of these three fractions now. So let us write the formula. The formula is nothing but, already we have learned, HCF is equal to HCF of numerators by LCM of denominators. Now let's see how we can find the HCF of these fractions by using this amazing formula. Let's see now. See, therefore HCF is equal to HCF of numerators. The numerators are 1, 7, and the 16. See, if you see then 1, 7, 16. 1 and 7 and 16. These three are the co-primes. Got the point? These three are the co-primes. So only we now the HCF of co-primes is always 1. Why? Because they have the common factor only 1. That's why they are calling as co-primes. So their HCF is always 1. So the final answer is 1. Why? You can check 7 minus 1 is, for example, 6, 1, 7, and 16. 7 minus 1 is equal to 6, and 16 minus 7 is 9, and 16 minus 1 is 15. And so for last, the final difference, small difference is, this difference is 6. As the 6 is not a factor of these three numbers, so we need to factorize the 6. What do you get? 2 and 3. And also 2 is a factor of 16, but it is not a factor of 1 and 7. And 3 is not a factor of nothing. That's why here we need to take 1. You got the answer? But easily we can see that 1, 7, 16 are co-primes, so that the common factor is 1. That's why that would be considered as HCF. Got the point? So 1 is the HCF of 1, 7, 16. Now let's find the LCM of denominators. LCM of denominators is nothing but here 9, 5, and 45. 9, 5, and 45. So 9, 5, 45. Yeah, the largest number is 45, and these see, and we need to see 9, 5 is 45, and that's why I'm putting the 9, and 5 is also factor of 45. I'm putting the 5. So that's why because 5, 9 is 45 easily. That's why the final answer is 45. So the HCF of the given fraction is 1 by 45. Other fine. So was it awesome, my students and friends? It is an amazing shortcut technique to find HCF of the fractions. So fine. That's all. That's all for this lesson. Let's go to the next lesson.